Let's solve some rational equations. I've got a bunch of examples for us here. When we're solving rational equations, there's a few different things we need to keep in mind. And the very first and most important is that we have domain restrictions. When you're dealing with fractions, we cannot have any zeros in denominators. So when we're solving, we need to be super careful that we don't cause this to happen. So how I'm going to do that is by looking at my equation at the very beginning, taking each denominator and restricting it so that it will not equal 0. In equation number 1, I want to make sure that neither my first denominator of x plus 1 nor my second denominator of just x equals 0. So x plus 1 cannot equal 0 and x cannot equal 0. Well, that first one needs a little bit of solving, so let me subtract 1 to determine that x cannot equal -1. So these two values are off limits. If my answer comes up as either x is 0 or -1, we're going to have a problem. So I'm just going to put these off to the side and keep them in mind for later. Now I go ahead and solve. When we're solving rational equations, generally we like to just clear denominators first. Looking at my entire equation, I want to find the LCD of all of those rational expressions. My first denominator is this x plus 1, and my second denominator is x, which means that I need to multiply by both x and x plus 1, and I'm going to multiply to everything in the whole equation. On the right-hand side, I multiply by x and x plus 1, and on the left-hand side, I multiply by x and x plus 1. Now remember, we can only multiply by one thing. So if I want all of my fractions to cancel, I need that one thing to include both of the denominators. That way, on the right-hand side, I can cancel my denominator of x, and on the left-hand side, I can cancel my denominator of x plus 1. So I was able to reduce both of those rational expressions, and now I just multiply what's left. On the left-hand side, I have x times 4, and on the right-hand side, I have 2 times x plus 1. On the left, I'm going to write that as 4x, and on the right, I distribute to get 2x plus 2. This is way more friendly. Let me solve for x. And I find that x equals 1. Now remember, we did have a couple of domain restrictions way back in the beginning. My domain restrictions were that x could not equal 0 or -1. But I got an x value of +1, which means that we didn't violate those restrictions. So this solution is just fine. If you want to go through the second couple on your own, go ahead and pause the video, but I'm going to go ahead and clean up, and then I will go through it with you. Before I get to solving, I want to make sure I establish my domain restrictions. Looking at each of my denominators, I know that a plus 5 could not equal 0, and a plus 2 cannot equal 0, which means that a cannot equal -5 or -2. I'll go ahead and move this off to the side, and then I will solve. To solve, I want to make sure I multiply the entire left-hand side and the entire right-hand side by the LCD. So I need to include all the factors of the denominator of each fraction so that the denominators reduce completely. My first fraction has an a plus 5, and the second one has an a plus 2. So I need both the a plus 5 and the a plus 2 on the left and the right-hand side of the equation. On the left, the a plus 5s cancel, and on the right, the a plus 2s cancel, leaving me with 12 times a plus 2 on the left and 4 times a plus 5 on the right. I will now distribute and solve. So my solution is a is -1/2, which does not violate any of my domain restrictions. So this is my answer. Let's go ahead and do one more. Of course, I'll look for those restrictions first. C minus 3 cannot equal 0, and c plus 1 cannot equal 0, meaning that c cannot equal 3 or -1. Multiplying by the denominator of each fraction, I'm going to multiply by c minus 3 and c plus 1 on both sides. On the left, the c minus 3 reduces, and on the right, the c plus 1 reduces, leaving me with 7 times c plus 1 on the left, and on the right, I have 3 times c minus 3. I distribute and solve. I found c is -4, which doesn't violate any of my domain restrictions, so this is my solution. Let's go ahead and do just a couple more. In these examples, notice that I now have 3 rational expressions forming my equation. So when I go multiply, I need to now multiply all 3 of these equations by my LCD. If you want to try it on your own before I get to them, go ahead and pause the video, but I'm going to go ahead and start working through number 1. I still look at my denominators and find any values of m that would cause there to be a 0 in the denominator. So m minus 2 cannot equal 0, m cannot equal 0, and m minus 2 cannot equal 0, but I've already established that over here, so I'm not going to write it again. M then cannot equal 2 or 0. My LCD needs to consist of the factors of each of my denominators, and I'm going to multiply all 3 fractions by that LCD. So I need an m and an m minus 2. My m minus 2 reduces in that first fraction. In the middle, the m reduces, and at the end, the m minus 2 reduces. So on the left, I have 1 times m equals 8 times that remaining factor in the middle is m minus 2 minus 3 times the remaining factor here is just m. Now I simplify and solve. M, again, doesn't violate any of my domain restrictions, so this is my solution. Let's do number 2. Looking at each of my denominators, n cannot equal 0, n minus 6 cannot equal 0, which means n cannot equal 6, and then n cannot equal 0 again, but we've already established that. So my domain restrictions are that n cannot equal 0 or -6. I multiply all 3 fractions by my LCD, which needs to consist of an n and an n minus 6. My first fraction, the n's reduce. In the middle, n minus 6's reduce, and at the end, the n's reduce, leaving me with n minus 2 times n minus 6 minus n minus 3 times n, and that equals 1 times n minus 6. I will simplify and solve. N equals 3, which again doesn't violate any of my domain restrictions, so that means that this is my solution. And that's it. Thanks for watching, and I'll see you next time. Bye.